Welcome to our Wharton webinar series. My name is Robin Turner, and I'm the Associate Director of Lifelong Learning and Alumni Relations. Today, we have a very special webinar for you, and I'm delighted to welcome the Wharton Moneyball professors, Eric Bradlow, Cade Massey, and Addie Weiner. Eric Bradlow is the K.P. Chow Professor of Marketing and Statistics and Vice Dean of AI and Analytics at the Wharton School. Cade Massey is Practice Professor of Operations, Information and Decisions, and Faculty Director of the Wharton People Lab. Addie Weiner is Professor of Statistics and Data Science and Faculty Director of the Wharton Sports Analytics and Business Initiative. Today's webinar is going to begin with Cade giving a brief overview of what is Wharton Moneyball and why you should be tuning in weekly. Following his introduction, Cade will lead the team in a lively discussion of the impact of AI in sports. You are welcome and encouraged to submit questions at any time. The Q&A button can be found on the top right side of the screen. If you don't see the Q&A button, please exit full screen mode. And finally, for closed captioning, simply click on the CC button at the bottom right corner of the video player. And now, please join me in welcoming Cade, Eric, and Addie.
Thank you, Robin. Thank you, alumni, for joining us. On behalf of Addie and Eric, I'd like to tell you how pleased we are to be here. We love the chance to visit with you guys. Periodically, we've done special Wharton Moneyball sessions, maybe 2 or 3 times over our history, and we've always enjoyed them, and we always learn. We want to give you just a little bit of background before we start off, and I'm going to kick it off by describing a bit of what we do. This show has been going on weekly since March 2014. We just came past our 12th year anniversary. We do it weekly, and we do it almost every week. We say 48, 49 times a year we're on. We have guests. Audie will talk a little bit about what those guests are, but in general, we're using data, models, and a little bit of behavioral science to explain what's going on the field and off the field. We try to cover a wide range of topics. And overall, we try to do it with a little bit of personality, a lot of math, but also a little personality to keep it fun. I'm going to pass it over to Audie to continue giving you some background.
Thank you, Cade. So one of the things that's actually our background for each week is to decide what we're going to talk about. It's actually become pretty easy over the years. We're mostly concentrated on what's happening in the week of sports, which would be big sports moments like if we're approaching the Super Bowl, or if it's spring training, or if it's a big golf tournament or tennis, we'll focus on that. The Olympics we get around to, of course, every 2 years, winter and summer. And those are the ways we kind of generate the main topics of each week. I would say that we do approach everything with an analytical flair. So everything we talk about comes a statistical angle. And that means that we have lots and lots of regular ideas that we bring back into almost all of our conversations. Big ideas you might remember from being a Wharton student. Regression analysis features prominently, Bayesians, base rates, decision-making under uncertainty, the effect of randomness. This is our bread and butter, and we approach each week's statistical questions in sports using those lenses, and of course, many more. Sometimes we do digress. So I will point out that when the sports worlds closed down in 2020, we spent about, I would say, a year and a half talking about COVID. In fact, the first 6 months, all we did was talk about COVID, but from a very statistical and rigorous lens. And we were pointed out all over the internet as a great place to go for serious conversation that's evidence-driven, statistically driven about COVID, which I think was a place that there wasn't that much information. And we continued that for a while. We still venture into kind of general topics. We've actually had several shows on firefighting, particularly out in the wilderness, and foliage analytics. And every now and then we talk about things that are not exactly sports. On the guest side, usually we get a guest who's is topical. So this past month, we've already seen Theo Epstein to talk about the baseball season, which is just starting. We've had Chris Collingworth talk about football. And of course, we've had athletes like John Smoltz. And of course, every July 4th, we talk a little bit about Eric's favorite sport, non-sport, competitive eating. We've had Joey Chestnut. So that's kind of how it goes. And that's, it means each week is refreshing and new. And in fact, I'll just turn it over to Eric to finish us off.
Thanks, Adi. So first, we record our episodes usually on Tuesday afternoons. When Cade's in town, or all of us are in town, we'll sometimes record it live inside a studio. For those of you that don't remember, right inside of Huntsman Hall, there's a studio. When possible, we try to record it there, but otherwise we record it over the internet. We drop the episodes on Wednesday. As Cade said, and when he introduced us, if there's a big week in sports, we may actually drop an extra episode. Matter of fact, we've been to the Super Bowl many times. We've been on, if you like, Radio Row. So that's something we do. I think, as Adi said, we do both current events, but I would say an evergreen mix, which means each week we probably cover 3 or 4 different sports. But we try to also not just do things at a surface level, we try to do things at a deeper level. So you'll rarely hear us say, let's just talk about all 15 things happened in sports, because that typically does not allow us, as Adi said, to get to the statistical rigor that we want to address these topics with. How can you follow us? Well, first, you can follow us on Twitter. It's funny because I tweet from my account on Twitter, but I pretend as if it's Wharton Moneyball. I'll be like, Wharton Moneyball just found this very interesting that Bam Adebayo scored 83 points. Of course, it's me speaking as if I'm Wharton Moneyball. You can find us on YouTube. You can follow us on LinkedIn, which means not only Wharton Moneyball, but the entity for which I'm the vice dean, which is Wharton AI and Analytics. Obviously, Cade and Adi are both co-directors of something we call Wasabi, as Robin said, the Wharton Sports Analytics and Business Initiative. You can follow that on LinkedIn. And of course, we're a podcast, so you can get us on Apple, Spotify, Acast, iHeart, YouTube, Knowledge at Wharton. And of course, as it says in tiny font in the upper right of your screen, we're now also on the Wharton Podcast Network. So you can listen to us for free. You can listen to us every week. There's also a library of episodes, and please also tweet or X at us at WMoneyball. So without further ado, let me turn it back over to Cade.
Thank you, Eric. The topic today, of course, is AI in sports. Sports being a good lens for seeing what AI looks like at the frontier and on the ground right now. All of us do work in sports. We continue to do research on sports. Our fourth member, Shane Jensen, isn't here today, but he's an active member in the show and actively involved in the sports industry as well. We thought we'd start with examples from sports. We'll give you a few. We're interested in hearing your questions and broadening the discussion, but to warm us up, we're going to give you some examples that we've been hearing about and thinking about recently. Adi was just at the big sports analytics conference every year. The MIT Sloan Sports Analytics Conference just had its 20th anniversary. Adi was up there, and Adi's going to kick us off with his own example.
Thank you, Cade. So actually, before I go to my specific example, which were generated from my attendance at the Sloan Sports Analytics Conference, although I think it's fair to say it's just sports in general with kind of an analytic kind of angle, I'm just going to lay the groundwork and help you clarify what we as academics understand AI to be, and this might actually help you think about AI in your own work and lives. So AI, of course, has been around for a long time, but we're not talking about the AI from the 1970s. We're talking about generative AI from this past couple of years. And I want to make a distinction between what people have long understood to be either machine learning or statistical modeling, which have often been included under that AI rubric. Why? Because it's not traditional statistical models using mathematics. It's often what we might call black box modeling. And there's lots and lots of methods which have been made possible through the introduction of widespread computing and powerful computers that are widely available. So in that sense, we couldn't be doing this thing called machine learning if we didn't have computers, but it's not what we're going to be calling AI. And what does that machine learning do? That machine learning does lots and lots of things that have been involved deeply in sports for a long time. Particular, how do you model things and make forecasts and predict future value and understand essentially the world through statistical lenses and using statistical models that are not traditional. That's machine learning, which many people would call AI. And I want to make that clear that when we're talking today, we're not talking directly about that. We're talking about generative AI. So generative AI is what's new. It's built through these very large deep learning networks trained on trillions of pages. And in fairness, the generative AI has learned how to program and collect data and organize that. So it can do that machine learning almost on its own, which is really important to understand. But that's not what we would be calling AI, the machine learning. We're talking about generative AI, which is this tool that you use through ChatGPT, whether that's Claude or Gemini or your favorite, if there's some others, you might be using those. So generative AI is a different animal. And I want to talk about that now that we have that straight. Where did I see the examples for generative AI being used, say, in sports, particularly from my return from Sloan? So I'll say two examples that are quite related. One has to do with the growth of the analytics departments inside the teams. So if you don't know already, baseball has had the longest relationship with AI, and it of course has the largest numbers of analysts on the teams. That it's very big. The smallest teams have at least 10. The largest, probably the Dodgers, might have 50. It's a big activity. The other sports are much smaller, and what AI is doing, generative AI is doing, is allowing that small group of people to do way more than they were able to do without generative AI. So the programmers program faster, the statistical models program faster and better, data is more readily available. And this means that the projects that were not being done are now being done, or at least more likely to be done, because AI is making them much more efficient. So that would start off with that. And I think that's a lesson we're all seeing in our own lives. Is
Adi,
efficiency.
I would probably say what you just said is true of every business, and that lots of smaller businesses today, without the extensive resources, can apply AI and statistical analyses more readily.
Right, because they don't have to hire more people. They can have their current staff. Actually, just saw an article, I think, in the Wall Street Journal talking about how people are busier than ever, and it's not because AI has made them more inefficient. In fact, they're the opposite. They're so efficient they can do so many more. So that's the first example.
Well,
and the second,
real quickly, I just want to elaborate on what I think that means for these smaller groups, because the main sport that I work with is football, and it's a smaller group sport. One of the things that happens in these organizations is that they're tasked with so many operational processes. They're just producing reports in some sense, and they're helping basic functions. They have this long queue of projects, R&D projects, that they want to get to. They're dying to get to, and it's just hard to get to them. They don't have the capacity. And what's happening now is they've got more capacity because the mundane aspect is more readily automated, and they're able to shift more resources. And so it should be really elevating the quality of thinking in the buildings, because they start doing these R&D projects that always got crowded out before.
Yeah, Kay, just to build on what you said, Kay, just quickly. The biggest challenge when I started doing work with the Eagles was, how do we take it so that the sophisticated statisticians that were hired cannot spend as much time on operational tasks, which is part of the job. So what you're talking about, I think, is the classic, what we're calling redeployment problem now in AI. The tasks that people still have to do are getting redeployed to artificial intelligence. A lot of times what's called agentic AI, it's now automatically produced. And then that allows the more sophisticated people to spend more time on the complex tasks.
Right, and it gives everyone more time, because you do what you had to do much quicker, and that gives you more time to do other things. And that's a message that I was hearing repeatedly from people at teams while I was at Sloan. So the second one, and this is in some level pretty frightening, I think, and not really frightening, exciting, but a little bit scary. What the AI is allowing people to do is make part of their skill set things that they would have thought unimaginable before it. So, for example, I have many of my students, many of them work for professional teams. And most of my students are trained as statisticians, or they're trained to be learners and statistical modelers, not what you would call software developers, or people who develop pipelines and dashboards, and what you might call engineers. This is what our CS department has excelled in, while we've excelled in other areas of machine learning. What is happening with AI is those statisticians are now able to do that task without having to program. In particular, Claude is exceptional at this because of its particular way that it is excellent with coding. And you can download skills which allow you to talk to the AI and have it build things that you couldn't imagine having built before. And I was able to see some of that being done by some of while I was at the conference. And it's amazing because it's made everyone able to have in their skill sets the skills they didn't have without really knowing. Now, I'm going to throw out a warning sign. I don't believe this is a good idea to have people who don't know statistics use AI to do statistics. It is it's almost like using AI to practice medicine. Yeah, I don't have you answers, but are you really going to trust it? So I'd be careful with that. On the other hand, the development side, that's a task that just is going to, you can decide whether it works or not, and it does or it doesn't. And that's where I think it's really producing incredible gains in efficiency, whereby one person now can do things that they could never imagined have doing before.
Sadi, let me just add one thing to that. Like something I've now done recently in my MBA class is I historically, like many of us, had done macros and other types of calculations in Excel. So I literally show them live in class. Let's ingest this Excel file into the large language model and ask it to create a web version of this with a dashboard, inputs, show the formulas, even ingest data. It can do that almost automatically now. And I have no skills in creating websites or anything like that. I have skills on the algorithmic side. And as you said, it was able to take my old software, if you'd like, and modernize it immediately.
I talked this week with the head of R&D for a baseball team, and this was one of the first things he mentioned was the incredible improvement in dashboards. And when you say dashboards, you might think, well, that's kind of boring, but it's actually the final mile. You know, we talk in logistics about the last mile. It's like, well, all the stats in the world, you have AudieWiner running your prediction models, but if they're not put into a form that can be communicated by the decision makers, consumed by the decision makers, it's all for naught. And so actually, if we're making big steps forward in better dashboards, more readily produced dashboards, dashboards you can experiment to find out what works better, that's going to help the decision makers, which is what we ultimately care about. So it's great. Okay, so I think Adi had a couple. I'm going to give you one. In talking with an executive in the NFL in the past week. This is a project I've heard about a little bit over the last year, and in some sense, it's a canonical LLM project, but it has a few layers I think would be interesting, and I want to get the guys' reactions as well. This team, like all teams, all professional sports teams working in personnel, worry about evaluating players as they draft them, so evaluating college players. So scouts put in reports. Part of those reports are about the character or the makeup of the athlete. It's the qualitative part of the report. And so the team has this challenge of integrating 2, 3, 4 scouting reports, the qualitative parts. The quantitative part's relatively straightforward to integrate. The qualitative is a bigger challenge. So this particular team, for example, has a guy who reads all of the reports. They might have reports on 400 players. They might have on average 3 reports. This is a lot of reports to go through to write down the integrated assessment of this athlete's character. And so they have a project in the last year. Can we build an AI agent to do this integration? And would we be happy with it when it happened? And so there's a thoughtful team, thoughtful, iterative. They built out a prototype and they're kind of sitting with it. They're kind of like, we don't know really how happy we are with this. We don't know if we can really reallocate our guy who's been integrating this to other work because we're not convinced yet that it's not missing something. But there's I want to get your reaction. There's some layers to this example. So let me just quickly put that on the table and get any reactions from Eric and Adi.
So my quick reaction just in 15 seconds here is this is a great example of a supervised learning problem, which means if you have the expert, the person that's been doing it for all these years, you have their reports, you have the underlying assets. You can now train a large language model because you have the human or the gold standard, you have the inputs. And so you can absolutely train. And as Adi said, it's a form of prediction. Now you have another set of inputs where you don't have the expert, and now you're trying to predict what the expert would have said. So I think this is a tremendous, great example of where AI would be very effective and get better over time.
It's also something that human beings, if they had to do this by hand, take too much manpower to do.
It's an exhaustive task, but you're looking for an edge anywhere, and if you can better assess the player's character, you're going to have an edge. Let me tell you a couple layers in here that jumped out to me. One, when they built this prototype, it has multiple agents. And so some of y'all have worked on these kinds of things. Most of us are not doing multiple agent models, but they have different agents with specialized tasks. So imagine, for example, a simple example is one agent does the aggregation, and then there's an editor on top of it that says, oh, it looks like you missed something, or oh, are you sure, or oh, and it kind of does the job that we do when we see LLMs work. But they actually go deeper. There's more variation in the tasks that they give. So, for example, one agent will be just pulling out data, extracting observations, essentially, like basically enumerating all the different observations that the scout makes. A different agent will come in and classify those observations into the whatever template they want to use. Another agent will come in and weigh the evidence around each of those observations. This is increasingly typical and a way of taking advantage of the specialized knowledge. You don't want these agents to have to make trade-offs. You want agents to do one thing really well, and then you want a different agent to do the trade-off from the other side. So that was to be interesting. Another thing that's interesting to me here is that you might think, are you taking the human out of the loop here? This concept of human in the loop. We need to keep a human involved.
Yeah.
Are you taking it out of the loop? And the idea is like, well, you've got them in there somewhere, but here's a very important place that you might get overlooked. All of the data is human. All the human expertise that resides in the scouts is rendered in their scouting reports. And the better they are and the better trained they are to report in a systematic way, the better the agents are going to be able to render value from that.
Yeah, let me comment on this last part. We dealt with this in a much larger scale when, my prior job to Wharton was at the Educational Testing Service in Princeton, and we were scoring essays, right? Adi Weiner writes an essay on some exam, you have humans score it. Now the question is, can you create an AI agent? We were doing AI back then to help doing automated scoring, right? And here's what we would do, Kate, and it relates to this. Let's imagine you have the 400 players. Imagine the AI agent, besides coming out with a report, also came out with a confidence score. So then what you do is you have humans come in, but when they're needed, which means if they're confident about the character of a player, those are ones that you don't need. Matter of fact, we call this in the educational testing world the master rater. You don't need the person that's really good at doing this to come in for all the tasks. Some are obvious. This person's very emotionally stable. This person's not. It's the ones near the cut line. That's where you need human intervention. So this is also a great opportunity to optimally allocate your resources.
It's great. All right. So those are some examples that we've seen in industry. We've got many more, but just to kind of warm things up. And then Eric wants to take us through an example of actually using this stuff.
Yeah. So for anybody that listens to Wharton Moneyball, which we hope everybody here continues and starts listening, if you have not, I'm very interested in the application of AI to specific kind of forecasting problems. So I'm about to tell you what I did, but I just want to be clear. I happen to use ChatGPT 5.2, but you could use any of the large language models. Wharton has a license with OpenAI. This is all that I typed in, and then I'm going to tell you, I'm going to go through step by step how it responded, and I want to go through step by step. I want to get Kate and Adi's response. This is everything I typed in. How many majors will Carlos Alcaraz win in his career? Provide me a point estimate and 95% interval. So I'm asking it for its best guess, that's the point estimate, and give me an interval where you're 95% sure his actual number of majors will be contained in that. Okay.
Eric, ground us before you start. Ground us in how many he has. What's the record?
I am. That's what I'm going to get to.
Okay.
Yeah. That's what's coming.
That's what the AI is going to do for you.
Right? Yeah. But by the way, let me just be clear. Eric Bradlow did nothing else. It did exactly the grounding before it even gave me any mathematical models, what Kate just asked for. So let me first tell you what it said. So here's what I used this is it speaking. Here's what I used as inputs. Alcaraz's date of birth, May 5th, 2003. So he's 22 years old. Okay. Carlos Alcaraz has 7 Grand Slam singles title now. So we know that any point estimate is obviously going to be at least 7, and any interval, has to be 7 has to be the lower bound, but it's probably going to be greater. So he's 22 with 7 majors. Here's how it computed it. So the first thing it says, this is it speaking. I want to be clear again. The only thing Eric Bradlow typed in is how many majors will he win in his career and provide me a point estimate. So anything else I tell you, I'm reading from what generative AI, the large language model, did. It said, first, I'm going to treat each slam as a Bernoulli trial, win or not, meaning the outcome of every tournament is he either wins it or he doesn't. It's a 1 or a 0. You can also think of it as a coin flipping model. Flip the coin. If it comes up heads, he wins the Grand Slam. Tails, he does not. Now, here's the part where it gets kind of squishy, guys. Using his slam conversion as a proxy for his ability, he's recorded 7 Grand Slam wins, which we know is true, in the 15 slam opportunities that he has. So he's 7 for 15. He's got 7 tournaments he's won and 8 that he's not won. Okay? So let me just be clear. For those of you that remember your frequentist or basic statistics, if all you did was count, you would say his rate is 7 out of 15. I'm going to apply that to some number of trials. Maybe he plays 50, 60 more majors. You could just compute the number times 7 out of 15, and that would give you a point estimate. That's not, by the way, that is not what ChatGPT did, but you could do that. Here's what it said. First, it says, I'm going to be Bayesian, and I'm going to put a prior distribution on theta, on the underlying rate at which he wins. Now, it put what's called a Jeffreys prior. It put a uniform prior. It put a beta half-half on it, which means its prior is like, let's pretend as if before he ever played a slam, he's got half a win and half not a win. Now, there's 2 problems I have with that. First, in some sense, it's shrinking, at least 2. It's shrinking towards a half, which, by the way, is extremely optimistic. Second, it's not a particularly informative prior. As a matter of fact, it's saying there's very little prior. But then it combined it and it said, so Eric, and by the way, it's not done yet. Eric, this leads to a beta 7.5, 8.5. And let me just quickly go over everyone how that works. His actual data is 7 wins and 8 losses. This is the nice thing about a beta. I take the 7 wins he actually has. I add the half from the prior, so he's got effectively 7.5 wins. I take the 8 losses. I add the half from the beta prior. It's 7.5, 8.5. And it says that's where I'm going to start my analysis. By the way, Adi, it's not done yet. It's going to start with saying the base distribution is a beta 7.5, 8.5. And by the way, it's going to assume conditionally independent Bernoulli trials, which we could debate also. So let me stop there and get your reaction. Then I'm going to tell you how it brought age into there. I'm going to tell you how it brought injury into there. This is like, I'm only halfway done. Any reaction, Adi?
My reaction is that I'm surprised that it went this way. I would have expected it to simply have looked at historical top players and looked at what their careers look like. In other words, just run to the class of people that are what I would call competitors or people who are like him. And I mean the Federers and the Djokovic's and the the Agassi's and McEnroes of yesteryear, and that would be his pool, and kind of compare him and then say where what's their range and kind of go for that. That's what I would have expected. So I'm kind of surprised that it went with the Bernoulli modeling.
It went with a modeling approach.
Eric, let me just say that as we just talked about multiple agents with the previous example, I think I would want multiple agents here. I would want to tell them I want to see multiple approaches. Give me 3 very different approaches to this, and then I can triangulate. It would absorb Adi's approach.
And I'll just summarize the other 2 things it did. It then said it recognizes there's year-to-year variation, so it added a multiplicative factor. To basically, say from year to year, his ability will scale up and scale down. And then it put an age degradation curve on it. It said it fit a model to the peak age of tennis players, said it was at 26, and then put a decay factor on every year to Alcaraz's ability once he reaches the age of 26. So putting all that together, this beta distribution, this coin flipping model, this multiplicative factor, this decay factor, it came up with a point estimate of 23 majors for him. And it came up with a confidence interval. You think my intervals are wide, Cade. 12 to 38 was the interval that it gave for his. But I'm just saying, I'm agreeing with Adi. I think it was fascinating that it was less like brute force empirical, like let's just look at the distribution of win rates for other top players. It went directly to what we would all call a Bayesian or complicated statistical model. It then slapped on an age curve, it slapped on year to year variation, and bam, that's what it did.
Okay, so
Great.
go ahead, Odd.
I was just going to say that just as a competitor, I asked it how many home runs Aaron Judge would hit this year, and it told me 28 to 54 with a 90 or 95% probability, which is pretty good. And it didn't do that approach at all. It just looked at his historical numbers and just added and just.
And by the way, just so you know, I know we don't have time to talk about this example too, Adi, but since you and I are Mr. Yankees here, I asked it also for how many home runs will Aaron Judge hit in his career, and it gave me a 95% interval from 459 to 638 with a point estimate of 560. So about 200 more.
If I were to actually critique the interval that I looked at, I would say that the point estimate was fine. It was around 43. I thought the range was okay. I think it was a little bit, quite honestly, I don't think it really was 90% or 95%. I think it was a little too shallow because I think it's overconfident in its range.
Well, that's interesting you say that because my main reaction to these ranges are they sound a heck of a lot better than the typical human ranges. So this is where behavioral science comes in. I mean, humans are famously too tight in their intervals, which means they're too confident. They know what's going to happen. And when Eric says it gave me 12 to 38 for Alcaraz career Grand Slams, like, wow, now that's 95% right. Confidence interval.
But it came, Adi, Chicade, it came from this multiplicative factor that's year-to-year variation that it's slapped on there that you simulate forward and you get this really explosion. And I like that.
It's appropriate. It's appropriate.
So I'll just say that with its Aaron Judge number, its upper bound was 54. I can't understand that. I can't buy because many times in his last 9-10 years, he's been above that. So how can you, that's ridiculous. It just has to have more on the top. And I think that's because it got trapped in symmetry.
Oh, it got trapped in symmetry. That's a real danger to us all, getting trapped in symmetry. I like this multiple agent approach. In fact, Eric, that's my homework assignment to you, to go back and ask it, give me 3 different methodologies. Give me your answer using 3 different methodologies, and we'll see what kind of variation.
I like it. Let me just say, by the way, I think what you just suggested is great advice. A lot of the advice you get actually is use 3 different large language models and see what happens. But I even say within a large language model, I love the idea of asking it for different methods and triangulating, and maybe even do some sort of model averaging. See how much weight it chooses to put on each one.
Well, let's take this moment for a quick moment on wisdom of crowds. I mean, we would say, be humble about your ability to say which model is correct and just blend them. I mean, often you're better off just blending. Get very different opinions and blend, because we usually aren't very sure which is the best approach. Why don't we wrap the examples there for now and see what kind of reactions or questions we have from the audience, and Robin has been collecting a few questions. We'll get those in a second, and I can get us started with some questions. I've been thinking a little bit about this as we warm into the day. Here's a question coming out of our discussions, especially those about team usage. Who do you think will benefit the most from AI in sports? And let's say the medium term, the next 3, 4, 5 years. Will it be the more sophisticated teams or the less sophisticated teams that benefit the most from AI in the medium term?
I'll take a stab, since I think it relates to what I'm talking about. I think the teams that not empty, the ones that are they're not going to benefit the most. They have to hire. I would look at the bottom. I guess the bottom not the what we call quartile 2. I think that's the right number. People that are on the low side but have some established work, they are going to really ramp up a lot of value. I think the learning curve there is steep, and they're going to get a lot of value with with what they have. If you look at what's going to happen to the Dodgers, they're already overpaying. They already have everything getting done. They're going to get more done, of course, but I think they're looking at marginal return already at the top. So I'm looking at not at the bottom, but not at the middle, sort of on the low side.
Okay, so that's a distinct model of technological use and adaptation value. So Eric, what do you say?
No, I was going to say the exact same thing, but let me say why. I say this through 20 years of experience. So we partner, as you know very well, Cade, you know very well, Adi, at Wharton AI and Analytics with companies all over the world And we have student experiential learning projects supporting them both in AI-related projects and data science. And what we've found out over the years is the highly sophisticated companies don't need us that much. The ones without an analytics team can't use what we provide because, as you said, that last mile never gets done. It's typically somewhere in that second from the bottom quartile is probably the optimal fit. So I would agree with Adi. I think that is who's going to benefit the most.
All right. Super interesting. I talked to one executive who said he was convinced that at least in the near term, the greatest returns would come to the more sophisticated organizations. He's a little leery of unsophisticated users using this technology. And he thinks those who really understand the pipelines and the questions and the statistical processes will actually do a better job with it. But I think it's clearly an open question. Let's go to some audience questions. The first question that Robin has surfaced, I'm just going to read the question. How will AI be used to influence recruitment and contract negotiations in professional sports? Specifically, if a player is having a rough season, will AI be used to predict whether she will continue to underperform or if she will rebound?
Well, I'm going to use this as an example of exactly the differential question that this is machine learning. This question has been around for a long time, and it certainly will. AI is making it more accessible. So if a team doesn't have its own PhD level statisticians to answer those questions, it could now have whoever they have learn how to do this with AI. So that'll change. I think some of the real dumb contract discussions that have happened on both team and player side will start to go away because you have at your disposal this really high-powered statistical consultant. But the actual statistical modeling isn't new here, and that's not what AI will be doing. It's just making it.
Yeah, I love this example because it fits exactly into what Adi led off this broadcast with. This is a machine learning problem that AI knows how to do. That's what it is. And so that's the great news for all of us, which is it's a machine learning problem that AI knows how to help solve that problem.
I want to give you one other way it plays a role here. When teams, the sharpest teams have very sophisticated models of player performance, and they're trying to value player performance, and they will dump anything into these models that provide an edge. So one role that AI can play, even for the sophisticated teams, is they can provide new data sources. They can use it to build some features off of computer vision. They can grab something about the biomechanical process, and they can dump it in these models.
Well,
and so
you may remember, Kate. Yeah.
Go ahead.
No, I was going to say, you may remember, Kate, for years when we would have guests on Wharton Moneyball, I'd ask the same question to every one of them. But this is before generative AI. If you could have a better data, better model, or a better organization, which would you take given you're trying to get something done? And 95% of the time, people would say better data. Like, data is the engine by which a competitive advantage is going to come. Obviously, the best form, the gold standard of data, is if you've run a randomized experiment. So you actually have a treatment and control. And so this way you can get a causal or a cleaner estimate of some impact or effect. But I could not agree with you more. I think the advantage is going to come from companies that have interesting data. And the other nice thing about AI today, Adi didn't specifically talk about it in his opening remarks, but he could have, is the multimodality of the data that which you can ingest. You could take audio data, video data, text data, and it can now put all of these things in what we call a common lower dimensional space. And so that's another massive advantage. You don't need a separate model for all these different data sources. They can all be combined.
Well, let me actually clarify one thing. Because I also, like Cade, we also talk directly to professional teams. And in some sports, in particular, I'll think of as soccer, or what the rest of the world calls football, is they already have access to incredible amounts of data, but they don't know how to use it. So it comes in, and remember, there's 47 professional leagues all around the world that they're looking at. It's not so limited as we are here. And there's streams of biomechanical data. There's event data. There's high frequency tracking data. There's 3-dimensional data coming from devices or video, and you just get monstrous amounts of it. And the teams just don't know how to do anything with it. And so, of course, you can try to pay for that. But what AI will allow you to do is take that data that already exists and actually start to get some use out of it, which can't be what good is data, even if it's amazing, if you don't actually open it up.
This is related to another question from the audience that Robin has surfaced for us. Do professional teams now build internal data sets to provide a competitive advantage? Here's one thing that strikes me about the AI revolution is that it's really leveling the playing field from a processing perspective, and it makes more data available. But increasingly, LLMs are trained on such massive data sets that people who have access to the LLM have access to the same information. And so you need an edge. You need something idiosyncratic. So a proprietary data set is an example of something that can provide an edge. So yes, this is something that some teams would prize if they're able to get that. It's hard to find a data set that's proprietary and provides an edge, but it's something that increasingly data is going to become common. So when those data sets exist, they are going to be a competitive advantage.
Let me just
also
follow
ask Adi.
Just a follow up because I heard something directly in a conversation about analytics at Sloan. And in baseball in particular, what professional players are doing, everybody knows. In fact, if you had to stick with the publicly available, not only data, but analyses, you aren't going to be too far off from what the individual teams are doing. The advantages in what you can do with not only minor leaguers, that's pretty well tracked, but college players, international players. This is where proprietary data is the edge that some teams have over teams that don't. And processing that, acquiring that, that's where you're going to see that. Now, that is true, of course, in soccer as well. But all that's now available. You just have to be able to do something with it.
I was going to ask a question, and I'm going to make a statement, and Adi, I'm not sure it's true, so I'd like your thoughts on my statement.
Okay.
If you think, but it relates to Cade's question, if you think historically, what would firms do with, like, say, large data sets? They do what, in statistics, we hope we might call computing like sufficient statistics, like summaries that really summarize the data. But in computer science, you might call this feature engineering. What features am I going to extract from the data that are going to allow me to do the task I'm looking for, whether it's prediction, etc. I'm going to make an argument, Adi, you tell me whether I'm wrong or not. Given the non-linear, complex way in which AI models can actually look for complex patterns in data, it's not obvious that I need to think about how to feature engineer what's going to be predictive because the model can do it for me. I'm not saying there isn't value in theory or there isn't value in kind of knowing what to compute that predicts, but would you agree with the premise that not only is data not necessarily as much of a comparative advantage because potentially a lot of people have access to it, but the secret sauce, like I know to compute on base percentage, like in the Billy Bean days, and I know to compute this, and I know to compute this. Well, the large language model is going to figure out for you what features to engineer. Do you agree with that statement or not?
Wow. My immediate response is
my
no.
My prediction is that Adi doesn't agree with that statement.
I actually don't agree with it, but in some cases I do. So when you're talking about problems like this, I like to divide them up into two kinds of problems. Problems that are what we would call in statistics low Bayes error rate, which is another way of saying humans, when you have full information, you can get the answer without any error. And then other types of problems we would call high Bayes error, which means that even with full information, you can't make a forecast. So when I'm teaching, a classical example of that is a low Bayes error rate is, does this picture have Eric Bradlow in it? Well, it's either yes or no, and it's hard to find the features to figure out what they are, but he's there or he isn't, and we'll figure it out. And then that kind of problem, I think AI doesn't need to. You don't need to have a specialist in human and Eric Bradlow detection. You can have the AI sort it out. But in other problems, and the classic example I do is it comes from I give in class. It's not a sports one. Is will this person who committed a crime go to jail again once they're released on parole? Well, you don't know that information. There's no way to know it. And so finding the features that will predict that is, I think, better off left to not AI can give it a shot, but I think real experts are going to be needed to do that because there's so much noise. So the more noise in the environment, the weaker the AI is going to be to find the features. And I think you would agree of that implicitly. And I will just say, I won't mention the team or the sport, but I spoke to someone at a team that says that they have two kinds of analysts: the statisticians and the feature creators. The people who know a tremendous amount about the sport, may have played it, been in it, but are not really a statistician to help create the features that the statisticians and the AI will then use.
I love that because we've long preached the importance of collaboration between analysts and experts. And what you're talking about is baking in an explicit role for the expert in the analytic process, this feature engineering. It's fantastic to see that collaboration improve. I want to raise one other hesitation about Eric's hypothesis, and that's the most obvious one to me, but it's a real constraint in practical situations, and that is sample size. You can't endlessly investigate all possible features if you've got a limited amount of data. And some of our sports are very constrained on data. I mean, professional football, we've only got a handful of games a year, and a game is really the outcome that you care about. They've got a finite number of plays within a game, and so you can quickly overfit your models when you've got that much limitation on the data side, which is going to constrain how much you can explore the feature space. Let's ask another question from Robin. Here's a very practical. I'm curious if y'all know anything on this front. One of our audience members asked, what type of usages have you seen in college sports? Is it only in the major sports, football and basketball, or in D1 power conferences, or has it expanded to Olympic sports and at smaller schools?
Well, Adi, can you talk about even just some of the work Wasabi has done with Penn sports teams? Or, I mean,
well, we are working with them right now. I can't talk about that because we haven't published any findings or made them public. But we here are working with our sports teams, and I can tell you that what we do at Penn is a tiny fraction of what the D1s are doing. Because they are so much more well funded. We have students. In fact, it's one of the great things that the students do. They have a Penn Sports Analytics Club, and they work with the basketball team, they work with the baseball team, the football team, helping them kind of prepare for games. That's some of the things that our students are doing. I can tell you that our baseball team has tracking data and like StatCast type stuff, and they have students who kind of help use that to get value. In fact, some of the students who do that are now working for professional sports teams. But what's happening is everybody is trying to get in on the analytics game because of the NIL money, the whole kind of professionalization of college sports. And that's not just the super D1 powers and football and basketball. It's trickling down to lots of sports, even lower down the pecking order, if you will. You're seeing everybody trying to get in on the analytics game. In fact, I'm starting to imagine, and this is going in the future, that some of the big schools will have analytics departments, which will be substantial. And they will be hiring this. It's a great time, by the way, if you want to be looking to go into analytics in sports. The collegiate world, and then if you push that down even to high school, they're all going to be using it and needing to deal with it. And this is going to be a jobs factory for people who love this and have the skills. That's my forecast. Disagree or not?
I just want to note that the college athletes these days were raised in technology, and they're much more open to it this generation than they have been in previous generations. And then there are some sports, some non football football-based basketball sports like golf that have been way ahead on data from the beginning. I mean, golf was one of the very first that knew exactly what was going on with the swing at every moment, and so they've just been ahead. But you might be surprised at some smaller sports, like I know a D1 school with the volleyball with a full-time data analyst on the volleyball team. So it's idiosyncratic. We recommended a biomechanic expert to the U.S. Olympic diving team in the last.
Wasn't volleyball one of the first ones that was ever done? Was it Gil Fellingham was his name, I think? His comment was he literally scored every player in volleyball on every play. Like this was literally one of the, before motion data or tracking data or any of this, he literally came up with ability scores for every volleyball player. He would literally sit in practice, watch every game, and come up with a score for I'm not making this up. I have a strong recollection of volleyball being one of the pioneering sports actually by tracking individual players, because it's like with all team sports, how much credit do I give to an individual player? And his motto was always, you must score every player on every play.
Super interesting.
That's what Pro Football Focus has done for years in football.
Exactly.
That was how they got traction, and then they just sold for hundreds of millions of dollars. Okay.
I'll also just comment on one last comment on that one. So Adi, you know this as well. My middle son obviously played squash at Penn, but let's be clear, he wasn't one of the elite players at Penn. So he made it his model. He actually did a lot of analytics with the Penn squash team. including helping them identify potential high school players and coming up players that were being missed using traditional metrics like rating points and other stuff like that. So I see that very much so being used. You've talked about this all the time in like these, you get these ratings coming out of high school and stuff. Well, the ability to potentially improve that with more sophisticated models, if it happens, is quote unquote big business.
Oh my God. And it's going to be necessary for, say, the Ivy League, because we're not going to be able to recruit at the levels that the competitors are in. And even though we used to be able to, trot out the Wharton or Penn degree, and that goes a long way, but when you're getting $500,000 to go to school somewhere else, it may not go that far. So we're going to need to come up with more maybe analytically minded solutions to this problem of attracting top talent. And I can tell you that it's something that they're already doing. And I've heard, they understand that we have to find talent where they are overlooked. And that's because if they're not overlooked, they're going to get big money somewhere else. We have to find our quarterback, for example, might be playing right now as a wide receiver somewhere, and we have to recognize that.
I want to stay with this youth orientation. There's a question from our audience. Given the intensity of kids' sports today, for example, competitive travel teams for 12-year-olds, could AI be used to statistically assess young athletes to give realistic chances of becoming a pro athlete or gaining an elite college scholarship? Let's turn first to Adi, because he's always had a bit of an angle on youth sports.
Well, I actually can tell you that the professional academies do this. They do it. They have analytical methods to predict your overall athleticism and try to understand the trajectory of that over time.
What do you mean by professional academies?
Well, there are professional academies. These are in baseball, it's perfect score, perfect game, and there are in soccer, they have academies. These are people who go to school and they learn to be athletes. And this is undoubtedly, that is typically only done at the highest levels, right? You don't just grab some random player and try to do this. So, and that's because variation is just in age curves is just so monstrous, right? So we've known for years that we've accidentally preferred older people with birthdays who are earlier in the calendar year. This is true in soccer. It's true in hockey. It's probably true in other sports as well, simply because they get pushed down the pipeline faster, right? So if you're a 6-year-old competing against 5-year-olds, you're going to look better just by that age advantage. And we've seen that, and there's and that's hard to overcome. So I don't know how well you're going to be able to do this, because the difference between a 12-year-old and an 18-year-old is so monstrous. This is why forecasting in baseball has always been the hardest, because you're signing high school students and you just don't know where they're going to go. Football has had this gigantic advantage that they have managed to farm out the intelligence arm to the colleges, and they only have to draft 250 people instead of 2,000, because that's what you would have to have done because you wouldn't know. There's a huge amount of uncertainty. Certainly AI on Magic can help. It's probably going to be an interesting problem, but right now we don't even have the data. We'd have to really collect high quality data among 12-year-olds and then roll it forward.
So that was going to be my answer, is that AI can assist in the following sense. It can be a great data integrator, data sources that weren't there before. It might be able to find and help utilize to make these types of prediction problems. And the second thing is, again, it's probably going to be some combination, as I mentioned before, of performance data, video data, maybe let's call it athletic combine-like data. And that's where AI can probably do a better job than most even statisticians, because how do you integrate all of these to come up with a forecast and prediction?
All right, we've got one more audience question, and then I'm going to have one closing question for us. The last question from the audience, again, and I want to thank Robin for the help that she's given for the whole session. This has been planned and strategized for months, and it's been Robin Turner who's been carrying the water. Last question from the audience. In 10 years, what part of sports decision-making do you expect AI to dominate, and what part will remain distinctly human? 10 years is a long window.
I think I'll give two quick answers each 10 seconds. If you're talking about on the field stuff, I think AI will become a much bigger role in what the manager, the coach, et cetera, decides to do on the field. Like, for example, the thing that Adi built with Ryan Braun about should you go for it on fourth down. I think that's going to become a much bigger part of what happens. I think off the field, I think you're going to see it help general managers evaluate contracts and the lifetime quality of a player much better. So you're going to get less, let's sign this 28-year-old to a 10-year contract for $500 million.
I'm going to just piggyback on that answer. I think goes back to dashboarding. The gap between what the analysts are doing and what the top decision makers are knowing is going to close in 10 years. That's how I'm going to see it. You're going to get, so for example, right now, the path to getting the answer to a fourth down, oh my God. First of all, they can't use computers in the game right now. So they have this huge, huge gap between the experts who know what to do and how to convey that information to the people who have to make that decision. That is going to close. That's going to be you can just sit and log into the computer, open up the dashboards, talk to the AI, and refresh yourself on all your decision making because all that analysis is going to be pumped in and ready to go and accessible. That's my forecast.
So building on what you guys have to say, one model we could go with for the next 10 years is that there's more standardization around in-game decision making and personnel choices, which is the answer that these two guys gave and seems reasonable. If that's true, where's your edge going to come from? And that edge is going to be whatever the humans are left doing. And I would put it on the softer side of things, which is going to be makeup and character assessment, which is really tough to do. And here's an obvious thing, but wildly influential, is only going to become more important as we see the standardization. That's how do you staff your team? Who do you hire for head coach? How are they at all these qualitative bits? How do they staff? And how do you fill the building? So that personnel side off the field is going to remain and probably become even more important as everything else becomes more standardized. I want to end with the following question, guys. I talked to a baseball GM who said something along the lines of, we talked about various uses of AI, and then he said, I'm insecure. He said, I'm insecure about not knowing what I don't know. And part of what this led me to think about, and we talked about a little bit with him, was we are the establishment. The folks I call and talk with about these things are the establishment. I'm relatively establishment. Revolutions come from outside the establishment. But how do you distinguish between like basically prophets and quacks? There's a lot of quacks out there. There's a lot of people selling snake oil right now. This GM was insecure about, how do I know what I don't know? How can I vet all of the claims being made? How can I make sure I'm not missing the revolution as I sit here relatively skeptical, trying to take advantage of things, but skeptical? What are your thoughts on how you balance complacency with overreaction? How do you balance complacency? All our managers, our leaders, our audience face this question. How do we balance complacency versus overreaction?
Since I see time, I'll just say in 15 seconds, I think you start using AI, you start using it for decisions. I like your triangulation method, Cade, and you can always check AI on previous decisions that you've made to see the degree to which it would provide an accuracy. In some sense, use out-of-sample forecasting as your guide, but you observe the out-of-sample outcome already. You can backtest it.
I'll jump in and give Adi just a little bit more time because I've thought about this a little bit more, but it definitely struck me that you need to be able to, it's related to what Eric's saying, but it's not always just sitting on your computer with the window from ChatGPT. It's also a vendor who wants to sell you a new product or an expert who says he can do this thing. You've got to have some way of evaluating those claims. You've got to have some way. Teams often give us the data, let us explore. If it works out, we're going to be your best customer, but we have to have a way of vetting it. But that also means we have to have the skills and qualifications to vet. We have to be sufficiently sophisticated to do good vetting. There have been lots of leaders in sports who have been taken by someone who said they were doing analytics and they weren't really doing good analytics. Adi.
Yeah, I mean, both the things you say I agree with. I think some teams are already purchasing outside vendor just to give them another opinion on something that they're already doing internally. This is absolutely happening substantially. They'll buy evaluation systems just to give another view on their own system. But I'm going to follow up. I think the right answer is you need people, and people are relatively inexpensive compared to what these vendors are charging for the use of their products. I think you need them as you need top analytics people who could potentially build these things if given the time and the right data to evaluate the products that you're using, so you don't get taken. And I think the right way to do that is the GM has to have confidants, right? We're people that can speak to them. I know, I mean, for many years, some of the world's greatest statisticians worked for captains of industry on the side as their private statistician, just so they can help them answer a question when needed. And I think that's the right way to go. You need to have your own internal people, not just the GMs and the assistant GMs, but your director of analytics, and pass it down to your associates. Take a look at these claims and evaluate them for you.
As good technology becomes more widely available, the real advantage is in your people. Why don't we end there on that note? Let's pitch it back to Robin. Many thanks to you guys for coming out, for your engagement, for your questions, and to Robin. Paul Grossman also being a great deal of help in the last few days. Robin.
Thank you so much, Cade, Eric, and Addie, for leading today's session, and to you, all of our alumni, for joining us today. The session has been recorded and will be available in our webinar video library in the coming days. Don't forget to tune in to the Moneyball podcast weekly, and we will go ahead and share with you later how you can go back to find that. Our webinar series is made possible by your support and contributions to the Wharton Fund. We hope you enjoyed today's webinar and will join us after an extended spring break for our next webinar, How Smart Technologies Alter Consumer Behavior, with Professor Shiri Melamad on June 4th from 12 to 1 p.m. Thanks for joining.